Hello, algebra students. We are going to continue our work with functions today. Our topic is today function notation. So I'm going to share my screen here so you can see the presentation. All right, and we are starting with the warm-up. You'll need paper for the warm-up. So go ahead, grab a piece of paper, pause the video, copy this down, and give it a try. All right, we are making a table. Well, we have a table here written. We just need to fill it in. And we are trying to figure out the range. So here's our kind of our rule for our function. This says put -2, -1, 0, and 1 in and see what we get for the output. So I have -2, -1, 0, and 1. And then I need to figure out, remember this whole thing represents the output. All right, so let's see. So this first one, when I input -2, what do I get? So I'm going to do -5 times -2 and subtract 1. So -5 times -2 is a +10, and 10 minus 1 is 9. So our first output is 9. All right, let's try -1. Again, I set it up the same way. I replace x with -1. And notice I use parentheses when I replace it, so I make sure I don't lose any positive or negative signs so that I remember this is multiplication. Remember, a number next to a variable is multiplication. So -5 times -1 is a +5, minus 1 would be 4. So when I put in -1, I get 4. All right, next one, we're putting in 0. Always nice to work with 0. So -5 times 0 minus 1. Well, -5 times 0 is 0, and 0 minus 1 is -1. And last, we are replacing x with 1 this time. So we're doing -5 times 1 minus 1. All right, again, we have to do the multiplication first, order of operations. -5 times 1 is -5. Then we subtract 1. So -5 minus 1 would result in a -6. All right, so find the range. These numbers here in this column represent the range of this function. All right, there is a question at the bottom of page 70 in your journal. It says, how can you use function notation to represent a function? How are standard notation and function notation similar, and how are they different? So in your journal, you'll see standard notation. So again, remember from last class, a linear function can be written in the form y equals mx plus b. So they've given you y equals 2x plus 5 on page 70. And function notation looks like this. All right, so one of the questions we could certainly ask ourselves is, how are they the same and how are they different? Well, let's see. These things are both the same. What's different is just this part of it right here. Okay, that's the only differences. It still represents a linear function. All right, we still have y equals mx plus b. It's just f of x equals mx plus b. Same idea. So let's jump to your journal, page 72, for some extra practice. It says evaluate the function when x is -4, 0, and 2. So you've done these several times now. You had it on a worksheet on Friday. Same idea. I think it's easiest if you first make a table. So I am going to make my table. I'm going to be putting in X values, and I'm going to be getting out G of X values. Okay, it doesn't matter what letter they use for the function. It's just they chose to use G here and H here. And I need to put in -4, 0, and 2. So I'm actually going to be doing the problem 3 times with each of those given values. So first I do -4. And this time our whole operation here is multiply whatever your input is by 5. So if I do 5 times -4, I get -20. All right, the next time through, I'm replacing the X with 0. So this time I have 5 times 0. Anything times 0 is 0. And the last time through the problem, I put in 2, and I get 5 times 2, which is 10. All right, so we've evaluated the function at all 3 values. All right, same idea on this one. I'm going to make my 2 columns. Again, I'm putting in the same input values, -4, 0, and 2, and I'm finding the corresponding outputs. So first time through the problem, I am replacing the H with -4. And again, I'm going to put parentheses so that I'm sure I don't lose my negative sign. So I put in -4 here, I'm putting in -4 over here. All right, I do my order of operations. I'm going to multiply these first. This is a -2 times a -4, which would be a +8. So I have 7 plus 8 is 15. So H of -4, when I input my first value, -4, I get out a +15. All right, next time through, we're putting in 0. So we have 7 minus 2 times 0. All right, 2 times 0 is 0, so we are just left with 7 for H of 0. And the next time through the problem, I'm putting in 2. Again, I'm going to multiply first. -2 times 2 is a -4. So 7 minus 4 results in 3. So the value of the function at 2 is 3. All right, look at the next slide. All right, now these are a little bit strange. They just want you to try to interpret what the notation means based on like a little scenario they give you. So in this one we have, oh no, we don't want it there, that'd be bad. Okay, it says let N of T be the number of DVDs you have in your collection after T trips to the video store. Explain the meaning of each statement. So things we need to remember are trips, right? Oops, go back. Gotta get my pen here. So T is trips to the video store, and N of T, or the output, is how many DVDs you have. All right, so remember this part here, this little part inside is trips. So on A, if I look at this, this would be 0 trips. And then if I look at when I make 0 trips to the video store, I have 8 DVDs. So to translate this, you would say you have 8 DVDs after 0 trips to the video store. And I'm going to leave off the word video just to save myself some room here. All right, so in other words, before you even make a trip to the video store, you already have 8 DVDs. All right, so using that information, if I look at this, I have a 3 this time. So this time we'd have, after 3 trips to the video store, I hate when the pen starts going weird like this. After 3 trips to the video store, you have 14 DVDs. All right, I'm going to see if switching hands makes this work better. All right, so this time we have something being greater than another. So remember, this inside part is the number of trips. So this would be something like you have more DVDs. And I can write this way, it's just really slow. You have more DVDs after, ooh, it's not really any better. After 5 trips than after, what the heck, than after 3 trips. It's weird, it's like making it look like caveman writing. All right, let's look at what this last one would say. So this is something about 7 trips. This is something about 2 trips. This represents how many DVDs you have. And this symbol here, a subtraction, means difference. So we could write the difference. Ugh. The difference between see if I can rewrite this. We'll try it a third time. The difference. Nope. Between 7 trips and 2 trips. And again, if you can't read this, it's written out nicely in the notes, and the link to the notes is in the folder in Schoology. So the difference between 7 trips and 2 trips is 10 DVDs. I don't know why the pen has decided to go crazy. All right, so what this says is the difference between 7 trips and 2 trips is 10 DVDs. All right, let's find a new one. All right, this time it says, find the value of x, so the function has the given value. So we're kind of working backwards this time. Grab the pen. So this time it's telling you, so here's b of x, and they're telling you they want to know what you get when that b of x is 20. So instead of putting the number in for x, this time I'm putting -20 in place of b of x. So I have -20 is equal to 3x plus 1, right? And then I'm going to solve that. So subtract 1 from both sides. I get -21 equals -3x. Divide both sides by -3. And I get -21 divided by -3 is 7, is equal to x, or x equals 7. All right, same idea on number 9. I'm taking 33, and it says that's what r of x is equal to, so I'm putting it in place of r of x. So 33 is equal to 4x minus 3. I'm going to add 3 to both sides. So 36 is equal to 4x. I'm going to divide both sides by 4. And this time I get 36 divided by 4 is 9 equals x, or x equals 9. Let's see our next one. Okay, so this time we're actually graphing a linear function. And so the first thing we're going to do is we are going to take these domain values that we have in this problem, -4, -2, 0, 2, and 4. We're going to plug those in for x, figure out what we get for our output, our s of x, and then graph these as ordered pairs. So I have to do this problem, it looks like 1, 2, 3, 4, 5 times, right? So the first time I'm replacing x with -4. So s of -4 would be equal to 1/2 times -4 minus 2. All right, so half of -4 would be -2, and -2 minus 2 equals -4. So that's this first one. All right, our next time through, we're going to put in -2 in place of x. So s of -2 is 1/2 times -2 minus 2. All right, half of -2 is -1. -1 minus 2 is -3. Okay, the third time we're putting in 0. So s of 0 is 1/2 times 0 minus 2. Half of 0 is 0. 0 minus 2 is -2. Okay, we do it again with 2. S of 2 is 1/2 times 2 minus 2. Half of 2 is 1. And 1 minus 2 results in -1. Okay, one more to do. We'll try to squeeze it in over here. We have s of 4, which is half of 4. Oop, half of 4 minus 2. If we take 1/2 of 4, we get 2, and 2 minus 2 is 0. So s of 4 is 0. All right, so now this represents a set of ordered pairs. So if you need to rewrite them, you can. So like this first point here, this is the point -4, -4. All right, so that's what that looks like as an ordered pair. This one would be the ordered pair -2, -3, the point 0, -2, the point 2, 1, and the point 4, 0. All right, so those are the points I'm going to graph. So to graph -4, -4, it says I go 4 units to the left. That's the -4. The first number is always the x direction or horizontal. So -4, and then I go down 4, and I make a point. Our next one, we have -2, -3. So this says go 2 to the left, down 3. Our next point is 0, -2. 2, -1 is 2 to the right, down 1. And 4, 0 is 4 to the right, and 0 up or down. And I just want to look and see, yeah, and it's asked you to graph this linear function. So after you have all your points graphed, you want to do your best to draw a line that goes through all of those points. And lines go on forever, so you don't have to stop, right? You can have it continue at that same direction and put arrowheads on the end to show that it's a line. All right, so your assignment today is in your book again. Again, the link, if it isn't in the calendar page, you can find the link to the agenda. on the home page for this course, under materials, should be the first thing that pops up. You'll find a link to the book there. Be sure to write down the assignment number, right? So make sure this is on your paper. You can use today's warm-up paper for the assignment. Remember, those of you working remotely, be sure to take a picture of your finished work and submit it through Schoology. You have a quiz coming up on Thursday, November 5th, that will cover up through what we did today. So we'll do a little more review with it tomorrow, and then you'll have a quiz. All right. Good luck, and just email me if you have any questions.